Hello, students. Good afternoon. This is Dr. Saurabh. So, I'm going to show you how to use your Bradford data for plotting a standard curve and how you can analyze unknown protein concentration using the same. So, this you will use to analyze your own data from last lab and make a plot and plot it in your notebook. Okay, that's how. So here we have a sample where on this column we have the concentration. So if you remember, this concentration was in milligram per milliliter, okay? And on this column we have the absorbance. This is the absorbance, okay? This being the concentration, this is the absorbance, and we had four knowns and one unknown, and this is the unknown concentration. Okay, so this is unknowns absorbance, not concentration. So what we will do after at the end of this session, we will get to know for this particular unknown, which is showing 0.33 absorbance, what is the concentration of the unknown. So that is the purpose of plotting this standard curve. Okay, so if you recall how I have told in the manual. Okay, so if you see in the manual, this is also described like this. So protein concentration is first column, absorbance is in second column. Now put the absorbance versus protein concentration, and then you can do it. So how we do it in Excel? So you select this and this to column. Don't select the unknown. Okay, go to insert, go to this particular one's called scatter, and here you get a straight line, semi straight line curve. Okay, you see I did not plot the unknown. Okay, so then what you do, you put the axis, so axis titles here. So the y axis, we can see the x axis, which is 20 to 2.5. This is the concentration, so you can write that as concentration. And y axis, it's the absorbance, so you can write that as abs or absorbance. Okay, so that is that. Now so this is the plot that is coming in. Okay, so next what we want to do, we want to add the trend line. So this looks like a straight line, so it should add the trend line. So you click any of these data points, you right click on it, you add trend line. Okay, so this, as I said, looks mostly linear. So you add the linear, which comes by default somehow, and you display equation on chart, display r square value on chart. So this is, both of them are pretty important. So r square, the closer it is to 1, it is the better your plot, data accuracy is, or the nicer your data is. Okay, they will get to know more about R square in your statistical course. So this is what we want. So better, the R square range should be between 0.95 to zero point 0.9 to 1. The closer it is to 1, the better it is. Okay, so this I'm moving. So this is the equation that we want. Okay, so we carry this equation or copy this equation to my PowerPoint, where I'm going to analyze this equation. So this equation is y is equals to 0.037x plus 0.053. So here, what we have, the equation here is y equals to 0.037 0.037x plus 0.053. 0.053. So here, if you can remember, the y is the absorbance and x is the concentrations. Okay, so that is important to remember before doing any more analysis. So y is the absorbance and x is the concentration. Okay, so now for the unknown, we know the absorbance. Remember here, so we, for y, which is the unknown, we absorbance is known. See, this is the absorbance, right? So 0.33. So we want to feed that into this equation. Okay, So we put the y equals to 0.33. If we feed that into this equation, we want to find out the x, which is the absorbance. So let's do that. So 0.33 equals to 0.037 x plus 0.053. Okay, so if you reorganize this equation, it becomes 0.037x. You have to show this calculation in your notebook. Okay, so 0.33 minus 0.053. Okay, so that is that. Okay, and that would become, quickly check, 0.33 minus 0.053, 0.277. Okay, that becomes 0.277. 0.277. So x would be 0.277 divided by 0.037. Okay, so sorry, calculator I want. 0.277 divided by 0.037. Okay, so unknown is, or x equals to 7.5 or 7.48. No, don't go beyond 2 decimal places. Megs per ml. Why megs per ml? Because the original concentrations were all in megs per ml. Okay, so this will also be in the same unit. Okay, so the x is equals to, say, 7.48 milligram per ml. So unknown protein concentration is 7.48 megs per ml. Okay, so that is how we do this. Okay, so I'm gonna stop the video now. Okay, since I have a few more minutes, what I'm going to show. If you, even if you don't put this in this order and your data is in the opposite order, like, if you have reversed the the x and y, it will still give you the same answer. So I'll just show you that. Okay, so here what I'm going to show is that, so I'm going to I'm going to rearrange this absorbance. I'm going to bring to this side, and concentration I'm going to bring to this side, because some people may get in this order also. So let's plot them. We're going to go to insert, we're going to go to scatter. Again, similar curve comes, so you go to add the axis. This is the concentration in megs per ml. This is the absorbance. Okay, and then, as I said, in the last one, what we did, we added the trend line. So we click one of this data point, right click it, add trend line. Linear comes by default. What you need to find, again, set the display the equation, get the intercept. So again, R square will be same because the same data set. If you look at this equation now, this is going to be slightly different because we have changed the x and y. Okay, so what I'm going to do, I'm going to copy this table to the next slide, because yeah, one second. So I'll do the calculation again. Okay, so now the equation is y equals to 26.3 minus 1.34. Okay, so here y equals to 26.3x plus 1 point, oh sorry, I think it's minus, let me double check. Yeah, 26.3 minus 1.34 minus 1.34. Okay, now here, if you look at the x and y's, the x is now the absorbance and y is the concentration. So let's put that as such. So y is the concentration and x is the absorbance. So in this case, again, absorbance is known, absorbance is known, from that concentration is unknown. Okay, so that is also we're going to do. So absorbance is known, concentration is unknown for the unknown. So let's put the x as the for the unknown as 0. Sorry, yeah, absorbance is 0.33. Let's see how much comes out. So y equals to 26.3 into 0.33 minus 1.34. Let's see how much comes out here. 26.3 into 0.33 minus 1.34, so 7.34. Okay, so it's quite similar as the other one, 7.34 megs per ml, because that is the unit of the protein. So that is, in this case, it is not absorbance. So y is the, sorry, y in this case is the concentration, and x is the, uh, in this case, y is the concentration and x is the absorbance. So unknown protein concentration becomes 7.34 megs per ml. So either way you put it, the purpose to show that either way you plot it, it's reversing the x and y. I think I deleted the other one. Or this way, the other way around, it should be fine. So you should put this plot in your part of the lab record. Okay, very, very important. So I'm going to stop this, and I'll then go ahead and post this video. Okay, so one more time, you need to show this calculation. So in the sense that you should show this plot, and also this calculation as in your notebook. You should get the sign in the next class, next lab, when you are coming to submit the lab report. Thank you for listening.